I'll get started. So yeah, I'm Tom Pedler. I'm the Corporate Energy and Emissions Coordinator for the City of Burlington. So Jody Janwin, who's also here, and I look after the corporate energy portfolio for the city. Like most of you, we have a crazy target that is in our corporate energy and emissions management plan of being net carbon neutral by in our operation by 2040. And if you guys have questions while I'm talking, like feel free to interrupt me, because if you're like me, you can't remember your question at the end of the presentation. So interrupt away. So yeah, we have this this target by 2040. I like to think of all of our buildings that we have as into three kind of distinct categories. So we have buildings like this, which is our Skyway Arena, which is no longer there. We knocked it over, and we're going to build that arena that's underneath it, which is a low carbon building. So we have all these buildings that we know are not going to make it anywhere near 2040. We're going to knock them over, and you know, it's the relatively easy part, I'll say, with like an asterisk of you know, getting to net carbon neutral. Isn't it pretty? Let's hope it works. And then we have this other chunk of buildings that I'm not going to spend too much time on. We have this other chunk of buildings that we don't really know what we're doing with, and that's like a whole other ball of wax and probably one of our biggest problems. But then we have this chunk of buildings that you know, this is Brant Hills Community Center, which I'm going to talk about, is built in 2003. It's going to be here for a while, so at some point we need to invest. Yes. We've started to consider that more, but in the case of this particular building, it wasn't meeting the community needs anymore. So that building that is underneath it is actually more than twice the size and has a whole bunch of more amenities and things like that. So, but yeah, I think things like that will be included in our next iteration of our plan a lot more, because it is such a big piece of the puzzle. So yeah, we have these buildings that are going to be around for a while, and we need to figure out how on earth we're going to make them more efficient and what's the most appropriate system for the building. So same funding as Adam talked about. So I'm not going to give a huge amount of detail on it right now, but I know everybody is usually curious about the timelines. This is our timeline for the funding. So we applied in June 2021. And we heard back in October of 2021 with some comments suggesting we change some of our answers and it would maybe make your application better. So we did those. And then we got approved for funding in December of 2021. And we signed our agreement with FCM in March of 2022. So Jody and I were talking about this yesterday, and I think she's right. It's probably the most amount of time I've ever spent on an RFP to try and get the scope right, because we really wanted to make the products of these studies usable. Right after we heard that we would probably be approved for funding, we started in on our RFP. And just like Adam said, we stole from a bunch of you. And you know, we used the guideline from the program as like the base of our RFP, which I'll talk about in a second. So we were able to get it out and get it awarded pretty much the same time as we signed our agreement with FCM, so we could just go right away. So we started our studies in April 2022, and we will be complete next month. Thought we'd be complete when I did this presentation, but we're not quite there. So I'm going to show you a bunch of tables from the results that we did. There's a few errors on them. Most of them are obvious, but the numbers are pretty much going to stay the same as they are in my slides. But yeah, there's a few changes that need to be made. So for our RFP that we went out with, we used the guideline from the FCM as the, you know, the basis for our RFP. And there's a lot of, if you guys have seen it, and I'm sorry if a lot of you are participating in the program, you probably already know a whole bunch of the stuff that I'm saying, but there's a lot of, you know, you can do A or B or C or a combination of any of those three. So we took that guideline and basically stripped out the stuff that we thought wasn't really applicable for us or wouldn't provide much benefit, kept a lot of the stuff that we thought would, and then we stole from a bunch of your RFPs and put that stuff in that we liked. So some things that ended up being quite beneficial that we're really happy with was, one of the things that we required the consulting team to have was a licensed quantity surveyor. So they had to use an actual cost consultant. They couldn't just say, oh, we've done this stuff before, and that's how much it's going to cost. So our construction costs will include contingencies and design and contractor mobilization and all the stuff that, you know, your typical energy audits kind of forget. Another thing, we required them to have a geothermal specialist as part of their project team, which ended up not being as significant, but it was good to have. We also required them to give us a RET screen model of each building when we were done, because there are certain funding streams that require that now. So we thought that would be a useful thing. They're going to do the modeling anyways. So give us a RET screen model now, so we don't have to make one later if we want to apply for funding. And then another thing that we didn't end up using because we were basically at our budget with the consulting, but we had an additional price for whole building envelope leakage testing. One, because we were just curious to see how much it would cost for some of these buildings. But yeah, it was nice to see that. And then we have a kind of order of magnitude if we want to do it in the future. And yeah, it was nice to have. We had pretty stringent criteria for our consultants because we had a huge spread on cost and understanding of the scope. So we made it so that, you know, you had to perform well in all levels of the scoring to actually be considered. So like a lot of people were disqualified. We ended up getting 13 bids. I don't think I can talk about the ones that didn't get it, but I can tell you that we chose Dialogue Design. And we paid 260 grand for our studies. So we maxed out the CBR funding. I can tell you that like our general idea for what we were looking for in a project team in a smaller amount of words that is in the RFP is we wanted to get away from those firms that typically do energy audits. You know, they go in, they do your audits, here's your VFDs and your lighting upgrade and your controls upgrade, and thanks, here's my bill, see you later. You can't use any of that stuff. So what we were looking for was, in theory, because procurement would never let us do this, but we wanted a group that could do our studies, and then at the end of the day, if we got a big chunk of funding right now, I could go to them with a change order and say, please go do that now. Go design the project. So that's what we were really looking for in a team, and we're 95% of the way through, and I think we're pretty happy with them. So here are the buildings that we chose for our study, and we only did 4. So we have Brand Hills Community Center, which is the building I showed you a picture of, and I realized that I didn't put pictures of the rest of the buildings in the presentation, and I apologize. So it's kind of a standard community center. It's got some community rooms, some gyms, admin space, 20,000 square feet. We have Appleby Ice Center, which is a 4-pad ice rink with some community rooms as well. Has 2 construction dates, and that's kind of important. It's basically 2 twin pads stuck together. They share no building systems except a fire alarm. So it's an interesting building once we get into some of the results. And we have 2 fire stations, which they have slightly different square footages, and it's only because one of them is built on a hill. They're the exact same building in 2 different parts of the city, built 8 years apart. So again, interesting results with some of the stuff that came out of that. So here's the kind of process that we had for the study, and Adam touched on it a little bit. And I keep telling myself not to forget this, but the members of the team that were involved in the study were Jody and myself, so the energy staff of the city. We had our asset management staff. We had our project managers that would manage the actual implementation of the project. We had some folks from finance. We had our operations teams from each of the buildings. And then from Dialogue, we had energy modeler, sustainability, mechanical, electrical, structural. They hired a building envelope specialist as part of their team. They had the geothermal specialist, and they had a cost consultant. So it was a big team that was doing all, I mean, not everybody's involved in every step of that process, but that's the big team. So we started with the site and energy system investigation, which is basically somewhere between a level 2 and level 3 audit in the building. So basically us just digging up everything that we could possibly find on the buildings, asking our ops staff some questions, getting all the information they need for step 2, which is where they built calibrated energy models of our 4 buildings. They were actually able to get them like really close. I was kind of surprised, but it turned out quite well. And then the third step is an integrated design workshop. And the aim of this workshop was, one, to go through the results of the first couple steps that we did. And then we had this massive list of energy conservation measures that you could basically apply to any building. And I forget how many items there were, but I want to say there was well over 100. Jody and I went through them first just so we had a starting point. But it was basically, we wanted to establish, of these measures, which ones did we see a good possibility of working for this building? Which ones were we kind of like, nah, do some analysis and show me the results and then we'll decide. And then there was a bunch we were like, no possible way, for whatever reason, you know, our building doesn't have that, or the ops staff can't deal with the construction that would require, or, you know, whatever. So with our list that we established in that meeting, and I don't want to forget this because it's a really weird ECM that was kind of fun that we found. On this list of ECMs was one that was reduce the window to wall ratio of a building, which I would never think of doing to an existing building. So we had it as, no, we're not going to consider that in all the columns. And we were in our meeting with our fire stations, and the ops staff said, no, wait a minute, go back. What is that? And we explained it, and they're like, can we do that? We're like, beg pardon? How would you like to do that? And they said, in our dorms, they're always blacked out. They always have garbage bags over the windows. We don't need that window. Can you look at doing that? And we're like, absolutely. So it was actually considered for that. So, I mean, don't discard any ECM, I guess. Anyway, so after that workshop, our design team was able to take all those measures and go away and analyze them all in a vacuum by themselves. And with all of those individual measures, they were able to create, we also had 4 pathways similar to Barrie. Ours are a little bit different. So we had the first one, which is a 10-year plan to get to 50%, and then keep it going to 20 years and get to a minimum of 80% greenhouse gas reduction. Oh, yes, that's greenhouse gas reduction, not energy reduction. We had basically take that first plan, shrink it down to 2 to 5 years. What would that look like? We had the next one, which I think we threw in as kind of just like a fun thing to do, but it ended up being really beneficial, which was maximum site potential. So, okay, consultants, you have all the money in the world. Do everything you can to get that building as low as you possibly can. So, you know, spend the $5 million and rip off the walls and put them back on. So that was very interesting with some of the results. And then we have our 4th pathway, which we basically came up with in the next workshop, which was, okay, let's look at all the elements of those first 3 pathways. As a team, let's discuss what works, what doesn't, take out things that we don't think will work, or, you know, ECMs that we thought maybe would work, and no, they're not going to. And then come up with this optimized outcome, which is the one that we are going to try to work into our capital plan, which I started doing yesterday. I don't think our asset management team was very keen on me asking for $10 million next year, but we'll get there. And then the final reports. So we're just in draft reports now. We should have them finalized this month. So, anybody have any questions before I get into some results? Oh. Okay. Cool. All right. So I apologize for the amount of numbers on these slides. I assume a lot of you are dorky like me and you'll like them. So here is fire station 2 and 7. We're going to look at the fire stations together because they are essentially the same building, but they were built 8 years apart by 2 different contractors and 2 different consulting teams. Fire station 2 has an EUI of 297. Fire station 7 has an EUI of 400 because it is terribly built. It is a very, very leaky building. So if you're ever looking for a business case for commissioning or involvement in construction, it's a good one. So here are most of the things that I'm going to talk about, with the exception of one slide for each building, is the optimized pathway that we ended up with. So for fire station 2 and 7, the measures that we came up with are the same, except for roof insulation upgrades. So these fire stations have pitched shingled roofs. Their attic space has blown-in insulation. we have records that show we already did an insulation upgrade at Fire Station 7, but I question how good it is or if it was done. So it's not on Fire Station 7 right now, but there's certainly some investigation to be done. And you can see both buildings, as far as greenhouse gas reduction, we're right around the 90% mark. High performance glazing, these are not crazy triple glazed windows. They are just good double glazed, thermally broken windows. We may change some of them to, we have a lot of operable windows in these buildings. We may get rid of that just because it's, you know, less leaky and less operator influence. We have some air sealing that we're going to do when we do the window upgrades. So all windows and doors, new seals. Automated exhaust system. This is a measure that's in there, but the only reason it's in there is because it's in the capital plan. It doesn't provide a vast amount of energy savings. This is the tailpipe exhaust system. That's, if you guys have fire stations, you probably have tailpipe exhaust. But this is just a controls upgrade to that system to make the exhaust variable speed. That's all that is. Electrify the domestic hot water system in both buildings and add solar to it. And then for the HVAC system, right now they have, each building has 3 forced air furnaces, gas with DX cooling. So we are going to change, and they also have a duct that just goes outside to a louver. That's how we get our fresh air. So we're going to change that to a dedicated outdoor air system with heat recovery, demand control, ventilation, all those fun things. And then basically an air source VRF system for both buildings. And that was kind of the easiest, and yeah.
Sorry. There's remaining emissions for each building. What's that associated with?
That would be the electricity that we're not able to offset
For solar?
With the photovoltaic, yeah.
Okay. And then one other question, are any of these items, do they pay themselves off like economically outside of the GHG?
Honestly, I'd have to check. Some of them will. I mean, the solar will for sure.
Yeah. Air sealing maybe?
Yeah, we'd have to look at the actual, I don't remember the actual measures, but there's analysis for each of the measures, and
okay.
yeah. And again, yeah, similar to what Adam said, if you want more details on anything, just let me know. I can't quite remember all the details of the study yet, so. Yeah.
Sorry, what were your GHG reduction savings for the high performance glazing only?
I don't know off the top of my head, but if you send me an email, I can get back to them. All right. Is that all I wanted to say? I think so. So here is what this looks like from an implementation point of view. So this is our business as usual 10-year capital plan for both buildings in gray. So in these particular buildings, you'll see pathway 4, and you can see that we've pulled some of those items back from where they are in the capital plan. And when I go through the slide that shows the different pathways, you'll see a little bit of why we did that. One is fire stations, if you guys probably know, they don't like interruptions. So the fewer projects that we can have, the better for them. So we've kind of lumped it together in basically a couple of, you know, we've grouped the big stuff together, so we're only going in and bothering them once. The other thing too, it allows us to save more on the cost of carbon, which you'll see in the next slide as well. So yeah, that's kind of what it looks like versus what the capital plan looks like. All right. So, apologize for all these numbers, but there's a few good ones. So these are the differences in analysis overall of each pathway. Oh, and I will say, I'll back up a little bit. So after we had each of the individual measures, you know, worked out by our consultant, they were sent to the cost consultant and priced as individual measures. Once we had the pathways established, they were sent out again and priced as grouped projects, so that, you know, you're only getting one, you know, construction, mobilization and bonding and admin and all those things for the different projects. So these pathways were priced out as they were just laid out, like I just showed you. So the business as usual column. So this is what we have in our capital plan for those projects right now. So pathway one, you can see the difference, $1.7 million. So we're a delta of just over $1 million. Pathway two, which is all the measures shrunk down and done basically as one project, which is 865,000. And then pathway three. So this, in this case, was one of the measures was removing all the brick on the outside of the building, re-insulating it, and putting the brick back on. There is a geothermal field in there. So you can see, like, and it's interesting to look at the greenhouse gas per meter squared, right? So 32 here, pathway one gets us to 2.8, so does pathway two and pathway four. And if you would like that extra little bit, you can pay, what's that, $2 million more? So it's an interesting look, and it just gets more and more extreme with the other buildings that I'll show you. And then this is the kind of the couple numbers that we're really basing things on, which is the 30-year cost premium for the project and the dollars per ton of greenhouse gas emissions saved. So you can see the differences between, 1, 2, and 4 are all relatively close. We have a lot more savings in the cost of carbon for pathway 4. And like I said, there was some implementation benefits to that pathway. So yeah, that's the quick look at, sorry, this is fire station 2, but fire station 4 is very similar. Probably only needed one of those slides. Okay. Yeah, see there's some existing errors. I don't think pathway 4 is 176 kilowatts in demand for a building that is 8,000 square feet, but
Just one question with
Yeah.
pathway 3 that you were kind of looking at through.
Mhm.
So I was just looking through, like, what is the difference between pathway 3 that gets you half that, but then increases the price? Is it solar installations, or what is the difference between pathway 3 that gets you to have the lower GHGs?
I'm pretty sure for these it's geothermal, and it's
Okay.
a lot of envelope upgrades.
Okay.
So in that case, we may have had triple glazed in there, and we may have had, and like I said, it was one of them was removing the brick and reinstalling it with more insulation, which
And
Was-
then there's a question here
Yeah.
for Christine.
Yeah.
Yeah, there's one online.
Okay.
So, the consultation that you did with your stakeholders in order to pick the, what do they need? Did you kind of, in that facilitation, did you talk about like what the results might be, like, geothermal is better than such? Like, did they have that context in mind?
So,
Or-
yeah, we had the results of the individual measures, not as a whole pathway, but we did have some results to say, well, yes, geothermal is better. It has a higher cost. Like, we had some of the metrics so that they could see the end results. So we had some of it, but we didn't have it all as one pathway yet. And that is a thing, and I'll just say it now so I don't forget, but that is one thing that we maybe said we would change, is we would add another workshop now to go through the pathways to see if, again, you can make some tweaks. So that was one thing that could have been a little bit better. Yep.
And yeah, we have one question online from Emily Cormier from Sault Ste. Marie.
Mhm.
She says, Tom, can you clarify the pathways again?
So pathway 1 is 50% reduction in emissions in 10 years and an 80%, a minimum of 80% reduction in 20 years. Pathway 2 is all of those same measures shrunk down to 2 to 5 years. Pathway 3 is anything you can possibly do to this building to get it to net zero. And pathway 4 was our look at the other 3 pathways, pick the good things, get rid of the things we don't think will work. And this is the plan that we want to implement. Yes. I don't know that we came up with that name. I think it was in the art or in the guide, but. Okay, so I'll move on to Brant Hills Community Center. So this is like the energy use, total energy use before and after. So this, of the 4 buildings that we did, was the only one that we were really able to get to net carbon neutral on site, without having that leftover chunk at the end, or very close to it. So, oh man, that's really fuzzy, sorry. So here are our measures that we came up with for Brant Hills Community Center. And this one is I think it was our best, it was the best building that we had. The most potential with probably the easiest implementation. So the building has.
Sorry, one more question I
Yeah.
just had with regards to the roof insulation upgrade, because I noticed that that's on this one, but it's not in any of the other buildings, the roof upgrade, the roof insulation. Is that because this one has a capital plan for replacing the roof and that was an
So-
opportunity?
Yeah, this one, like you'll see in the timeline, the roof and the HVAC are due now. So yeah, the roof insulation upgrade is, we're doing the roof, or we're going to do it hopefully next year. And we're going to increase the insulation as part of that project. High performance glazing and doors. Again, this building has a fairly low window to wall ratio. Not a lot of windows. So again, they're not crazy. They're not triple glazed. Like they're just good new windows and an upgrade from 2003 when they went in. And then we're going to electrify the domestic hot water. And this building, we did look at a heat pump water heater. In this case, it is just an electric resistance water heater. One problem with this building, and it kind of limited some of our HVAC options, is it hardly has any mechanical space. And there's not a lot of spare space in the building anywhere. So some of the larger measures, like a heat pump water heater or geothermal field or stuff like that, we would have actually had to add on to the building to have some mechanical space for those systems. So we'll talk about that a little more. But our library in the building doesn't have LED lights yet. So that was an easy kind of part of the capital plan already, upgrade the lighting and solar. We did have some discussion about the amount of solar that we can fit on the roof is very close to what we need. So we also explored some canopy solar in the parking lot. And we have that priced out as a separate option. And then for the HVAC, right now, it's a 20,000 square foot building. I think it has 8 rooftop units. So it's you know, there's no hydronic loop through the building. There's nothing. So to install something like geothermal was incredibly invasive, time consuming, and very costly. So we didn't end up with that, which I think we thought we might end up with, but wasn't the case. So we have packaged rooftop units with air source heat pumps, backup electric heat recovery, and demand control ventilation, and VFDs, and all those good things that you put in rooftop units.
Only because I have the number right in front and center of my brain, just for the difference between the package air source heat pump with the heat recovery versus a 4-pipe system is about $2 million. So that's just the interior part of the building, separate from the geo field, just to give an idea of how much that would have cost to do that within the building. It made a huge difference between going with geothermal or hydronic versus this package units.
Yeah, it ended up being just a vast amount of extra work. So in this case, our optimized pathway, we'll call it, is actually pathway 1. It's following along with the capital plan exactly how it is. That was the best option for this building. So you can see there's our business as usual, and I do apologize. These graphs all start with 2023, but I don't know how fast you guys can do projects. I can't do that this year. So we're gonna have to get them to shift their analysis 1 year so it makes sense. So yeah, this is what it looks like from an implementation standpoint. Yeah, just following along with everything. Yeah, so
We have a question.
yeah.
Yeah, Scott Prevost said, were heat pumps with natural gas backup heating considered or modeled?
No. No, they were not. Yeah. Yeah, we did have some, and it's very, we did have to add in an electrical service upgrade into the project cost as well. Yeah, so we did allow for that because the demand goes slightly above what is available. So I realized after I made this presentation that I forgot to put these graphs in for Fire Station 7. I really like them. Shows you your investment each year along with your greenhouse gas reduction from your original. So our first project where we do HVAC, roof, and solar, obviously is the biggest bang in this whole project. And, you know, we're just following along with a few minor things after that to get down to net zero. or close to it. So, yeah, yes,
Sorry to interrupt, Tom.
no.
Kind of a two-part question. That chart that showed the capital projects that are business as usual and then the pathway, was that something that you had the consultant sort of pull the information from the existing capital plans to say, this is where they're currently scheduled and then they helped you come up with the bundling of the projects and when they should happen?
Exactly. So one of the things we gave them right at the start was a dump from our asset management system to give them the life cycle of all of the elements in the building. We also gave them a copy of our 10-year capital plan to say, here's how much money we have to go along with those things.
Okay.
So that's how we built that business as usual.
That's really helpful. And solar, where do we see the solar in this?
Right, it's right in the joint of the
It's right at the
CV.
top. Okay, so you're starting with that. And I wonder what's the thinking there, like, because, we saw the chart, I think, from Adam in the beginning that said, okay, start with kind of the energy efficiency
Yep.
and electrification and renewables at the end. I'm just wondering, like, where does it make most sense to put
So-
solar?
That's a good question. And to me, it makes the most sense right after you do the roof. So you want to maximize that time that you have that solar array on. In most buildings, and I think that could be a concern in a building where, you might put on, a whole lot of solar and then you do a whole bunch of conservation measures and fuel switching, and then you have too much solar, which I don't think would happen in a lot of buildings, but I'm sure that opportunity exists. It doesn't in this building. So yeah, and we've done a similar analysis to what Adam was talking about, where we've done solar potential on all of our buildings. And we want to try and build that into our capital plan right after the roof, basically, is what we've done.
Okay,
So we're not necessarily doing it in that same order, but
got
the
it.
same idea.
Whenever the roof's done. So it could have been a few years back, but it just happened to be.
Yep.
Got it. Okay, thank you.
Okay. Talk about that. So again, here's our pathways. You can see pathway 1 and pathway 4 are exactly the same. You can see pathway 3 is considerably more expensive, and it does involve removing some wall panels on the outside of the building, re-insulating and reusing the wall panels, which wasn't a terrible measure, but it was quite costly for the benefit. You can see the greenhouse gas per square meter. If you would like the extra 0.1, you got a big price delta to cover. And then that is, like Jody said, that's a geothermal, an addition on the building, and lots of extra infrastructure. One thing I will say is we did actually apply for GICV funding for this project, and our application is I'm going to say a hybrid of pathway 3 and 4, because if the government if they're going to pay for 80% of it, I might do some of those ridiculous measures to get me the extra 0.1. So, okay, the large one. This is Appleby Ice Center, 140,000 square foot, 4-pad arena. I hope I'm not going over my time. We're good? Okay. I realized I weighed way too many slides, but so this is our total energy use before and after. Like I said, this building, and I really do wish I had put a picture of it, it is 2 twin pads stuck together. The ice plants aren't even close to each other. It's like the worst starting place to be with your building that has the highest energy use per square foot in your whole portfolio. So we were very interested to see what we would come up with for this building. So here's what we came up with, and I hope that I explain the HVAC and ice plant one properly without backpedaling. But we'll start off with the easy ones. So we're going to electrify domestic hot water and ice resurfacing water. This actually, the chart is wrong. It says packaged air source heat pumps. It's not. They're rooftop units, and I'll explain in a second. We, on the newer half of the building, which is built in 2009, 2010, it was probably one of the last buildings we built that didn't have LEDs. So it still has fluorescent lighting. So we'll upgrade that. Our ops team really wanted to put this measure in, and it does show some decent savings. They really wanted to try an RO water system in the rink. I didn't suggest it. So, but yeah, it was interesting to see the analysis on that. And then rooftop PV on this building as well. And it's split into 2 chunks to go with the ages of the buildings to go after the roof replacements. So the ice plant and the heating for the building. What we ended up with, and there was a lot of different kind of options that we looked at. What we ended up with was, whenever we do the ice plants for both of the buildings, we're going to put in an ice plant that is capable of recovering as much heat as we possibly can. We still have way too much heat for the building, so we still have cooling towers. We are going to install a hydronic loop in each half of the building that will carry that heat throughout the building. We'll connect it to bleacher heaters, unit heaters, and we are going to swap all of the existing rooftop units out for rooftop units with hydronic coils in them and DX cooling. That loop will have a water-to-water heat pump on it to bump up the temperature of that loop. And it also has a backup electric boiler, just in case we need heat when there is no heat available. And then with those rooftop units, we already have heat recovery units and things on the building, so we're going to upgrade those to more efficient units. And like I said, with all the other rooftop units that we're doing, VFDs and controls and all those fun things. So again, yeah.
Sorry, a technical question.
Oh, crap.
Your electric, your electric boiler, often when you size it for the full load of the building, it causes, you need a new transformer and you just get run out of the room. So that you mentioned a backup boiler, is it like partially sized because you have heat from your refrigeration plant to?
I honestly don't remember off the top of my head.
No,
I can look it up after.
no, it's just, it's always like, that's the crutch if your rake system.
I'm gonna guess that it is sized for the full load.
Okay, fair enough, thanks.
And I think we have a service upgrade in this building as well. So yeah, in this building, similar to Brand Hills, our chosen pathway or our preferred pathway was the exact same as the first pathway. Yeah.
Okay. The current ice rink refrigeration system, is it ammonia based or?
Yep.
Okay, so have you considered like a CO2 based? What sort of analysis went into refrigeration system upgrade?
We didn't look at CO2. I think that might be something that we would look at more in the detailed design of that measure. But right now it was just back with an ammonia plant. And I think that was more at the request of the operations teams because that's what they're used to. Too much change, not good.
So is it going to be sort of like a re with a heat recovery enhancement?
Essentially, that's what we looked at.
And the ice resurfacers, are you considering, will the gas fired Zambonis be used as a backup? Because electric might have, they
This
might
building-
not.
So this building actually already has an electric Zamboni
Oh, it's already electrical. Okay, awesome.
on one half and the other will be converted.
Okay.
Thank you. Yeah.
Just have an online question. So Luke Reeser Keller says, does the RO water treatment not require additional heating of the water? Our challenge with this has been heating water to make RO water and then chilling for ice, not an energy saver.
Yeah, so that was one thing that we do have, like I mentioned, the studies aren't final and we have some clarification. So one of the measures that we had on there was electrify the ice resurfacing, and we also have RO. So we need to have some conversation about what the actual measure they've included is. So yes, but I'd be interested. Sorry, who was that asked the question? Okay, may reach out to that because we don't have any buildings and they were very keen to try it. So it's always good to hear some operational tales from other cities. Oh, perfect. Right, so this building follows along with basically the capital plan as we have it. There are a couple things that aren't included on the business as usual side. There are 2 roof replacements that happen right before the 2 solar projects that you see on the green side there. Yeah, but there's, yeah.
Maybe this is a silly question, but if you're replacing a roof, you've got your solar that's providing electricity for your building, and now we're replacing the roof. Now we have to take the solar out of commission. How does that all work? How do we make sure that the building still has power when we're replacing it?
So they're net metered solar arrays, so we still have grid power. We still have all the power we need. Should we turn off the solar?
Okay,
And these solar will go on right after we do the roof or at the same time, depending on how the contract works. So we're just prolonging the time until we have to take the solar off and put it on again. But I would expect that, once we get to the, 20, whatever lifespan the roof has, we're taking that solar off, we're probably going to upgrade it at the same time.
Right, so when you're in the process of replacing the roof and the solar, you just go on the grid for that.
Yep.
Whatever,
Yep, exactly.
3 months or, okay,
Yep.
thanks.
Yeah. All right, so here's what it looks like from an implementation point of view. I don't have $6 million this year. Next year, though, gonna try and get me $6 million bucks. So this is what it looks like from the dollars and greenhouse gas perspective of the building. So, yeah, not a whole lot. You can see the two big chunks from the HVAC and the ice plants, and then you can see the two smaller ones, which are the solar arrays in 2029 and 2040, and then I don't know what that, I think that other one's lighting or some smaller measures. So here's a comparison of our 4 pathways. And Jody called me yesterday at like 5 o'clock and was like, I think there's something wrong. I was like, what? And she's like, pathway 2 is way better. And I'm like, oh, yes, it is. Why didn't we pick pathway 2? But there's a good reason. We remembered. So again, pathway 1, 50% reduction by 10 years, 80% reduction in 20 years. Pathway 2 is all those same projects shrunk down in the short term, basically to do them all at once. Pathway 3, everything we could possibly do. Look at that incremental capital cost of $41 million. If you would like to re-insulate the outside of an arena, it's very expensive. Same with geothermal for a part of your system. It's kind of fun to see, but not very effective. And again, you're going to get 2 kilograms per square meter less than our other pathways. But so pathway 2, this building, like I said, has 2 pads or 2 sets of twin pads. We operate this building all year round. And when we don't operate this building all year round, we'd only take 1/2 of the building offline. So pathway 2, although it's better, we can't do operationally to meet our ice demands in the summer months. So in this case, we're going to pay more, albeit not much in the 30-year cost premium. But we're going to pay more because, I think it really highlights the benefit of having all those people at the table to say, wait a minute, don't do that. We can't do that. Back up. So again, it was a very interesting analysis. I think we're happy with it. All right.
Find it so funny. Sorry. I just find it so funny that pathway 2 came out to do it over the short term came out way better than doing it over this longer span.
Yeah. And I think a lot of it was just the weird 10-year gap that we have with the 2 halves of the building. It's an odd building. I realized I didn't actually send Desi the right presentation because there were certainly more lessons learned than those 2. So, yep.
So Scott Prevost just has another question that he's just going to unmute and ask you himself.
Okay.
Go ahead.
Thank you. Thanks, Tom. I just wanted to confirm the hydronic HVAC conversion. So you said it was packaged rooftop units, and I was just wondering if that is correct, converting rooftop units, because then you would need piping infrastructure to go to all those units, and those would be just basically water source heat pumps then on the roof. Just wondering if you could explain a little bit more into that, and if that was compared against like the incremental cost of doing that versus just going with the straight air source heat pump solution.
Yep, I can definitely explain that. So yes, they're not heat pumps in the units. It's just a glycol coil in the unit. The water source heat pump would be on the whole loop to bring the temperature up. And we did have air source heat pumps in there. And I'm going to try and summarize the discussion around that. They're considerably more money for the rooftop units with air source heat pumps in them. They're heavier as well, so you need structural upgrades. So those were added costs. We knew that the piping was more money just in capital costs, but what we found odd with that was if we can't use that building, or if we can't use that heat in the building, we still have to use our cooling tower and basically use more energy to get rid of that heat. Then we're gonna use a heat pump, we're gonna use more energy to create heat in our rooftop units. So we said, would the delta between those two things, like, would that cover the cost of all that infrastructure to do a hydronic loop? And we said, well, it's very close. And it reduces the cost of our rooftop units and the complexity of our rooftop units. So we thought that the benefits of doing all that infrastructure in this particular case outweighed just switching to packaged heat pump units. And Jody's chiming in because I forgot something.
So the units are actually, they're not heat pumps on the roof, or they're just air handling, just fan coils basically.
Yep, with DX cooling on them. Yep.
And if I understand correctly, you forwarded the Skyway Arena
Oh,
mechanical brief. So this had already been explored in a facility, right? So it's because it's becoming like a proven
Yeah,
method, right?
that's true.
Yep.
Yeah, we, in our other new arena that we're building, it's not the same system, but it's similar in the way that it uses recovered heat.
Thank you.
It doesn't have a swimming pool. We have no buildings with ice rinks and swimming pool, and I'm kind of jealous of the ones that you guys have. So a few lessons learned. Yep,
Sorry.
more,
Just
yeah.
One more question.
No, it's-
Emily Cormier from Sault Ste. Marie asks, can you remind everyone of which staff from your internal project team were comprised of?
Sure. So it was energy staff, so myself and Jody. We had our asset management team involved in the process. We had our operations staff from each of the building, and the operations staff that was involved from each building was the supervisor of the building, the coordinator of the building, and one of their operators, like day to day, which I think was important. And then we also had our project management staff to kind of bring that real life construction element to things. That was everybody on the internal thing. Oh, right. And we had our maintenance analyst as well included. I forgot that. He would be mad at me. Okay, yeah, go ahead.
I have two questions. I think one you already answered, but considering there's a good heat recovery from the ice plants, was a geothermal ground source heat pumps considered?
They were,
Okay.
but the building is so unbalanced that we required, you know, additional infrastructure to make up the difference anyways. So it was just cost prohibitive. But I mean, it does add to the greenhouse gas reduction. Yes.
And there's a significant electrification, so was a battery energy storage system given a consideration?
Sorry.
I was going to mention this anyways, not so much energy storage, but there was definitely a large or a
right.
sizable conversation that happened with the businesses nearby, like what could it be possible, not so much to store the energy, but to just like pipe it across the parking lot to next door, because they would need energy as well. So that seemed too much for, I think, this project itself, but we were definitely spending a large amount of time in a discussion about how we can use this energy. Where could it be, you know, either shipped to or saved to and whatnot. But yeah, it was so unfortunate, it's so unbalanced, and
Yeah.
seemed not feasible to reach out to a private business and pipe it there at this time. Yeah, exactly.
Pretty much. I don't want to use our cooling tower. So yeah, lessons learned for this project. One was the timeline, and we really couldn't do anything about it on these projects just because of, you know, the timeline with, you know, when we identified them and when things were up for renewal. But I think in our future, you know, when we're going to look at studies like this, I think we have them 2 to 3 years before that capital, you know, large major capital project happens. I think we would bring those back a little bit because it does take time to do the study. It does take time to work with your budget teams to try and get some of that money. So I would say probably closer to 4 or 5 years ahead of time would be more accurate. Another thing that we thought might be good was we did a 30-year analysis for all these buildings. We do have one part that goes a little further, but it would have been good to look at each building with our asset management team and our user groups and, our operations teams and say, what's actually the appropriate amount of time to use for this particular building? So is, 30 years might be good for community center. Well, fire stations, maybe 20 years. And the ice rink, well, maybe it's like 40 years. So to maybe tailor some of those. Another thing that we maybe would have changed in our consultant RFP was have them identify the staff that are going to lead each piece of that process. Not that it went badly, but there was, we could have had some improvements for sure. There's other stuff that I've forgotten, but I didn't write them down, and yeah, that is all. I've talked for far too long, haven't I? Oh, okay.
I had a question about the measures, the long list of measures that
Mhm.
your consultant put together. Will you be able to use that list to do future projects, or would you have to kind of scope the whole thing again and start from scratch?
For sure. So that most of that list of measures is actually in the guideline from FCM. And then I think our consultants had added a bit to it. I mean, I think we could tailor it a little bit to the projects. Like ours was so big just because of the variation in building type that we had. Where, we had a whole section on process loads that was in, the ice plants and stuff like that. Whereas you wouldn't normally have that in. But we would just cut that out in fire stations. But yeah, you could definitely just reuse the same list.
Was there consideration given to carbon offsets potentially, let's say for a zero carbon building performance certification down the line?
We didn't really investigate them that much, but I mean, they're certainly discussed to say, that's the next step to offset that last little bit. We didn't look specifically at the performance certification. The other thing that we kind of thought was, yeah, we could look at carbon credits, or if virtual net metering becomes a usable thing, then, we can offset that last little chunk with a larger solar array over there kind of thing. Yeah.
And in terms of implementation, are these projects like going to be like the other state of good repair projects, or there's a specific way that implementation will be carried out, like design build with a measurement and verification component with that? So how is implementation being planned, the actual construction?
So I wish I had a better answer, but right now we're just trying to work them into the budget. And I mean, those ones that you saw that'll go, in the next couple of years, I would think that they would be design build, design tender build, commissioning and M&V and that sort of thing. I know that we would like to go to more of a, integrated design process or like a design build, but I don't see that happening for those first two. Just the way that our group is set up.